You can put in a similar net for mariculture, again, a positive to livelihoods and economies, to tourism and recreation, to sense of place. Clean water is certainly important. But this time, the habitats thing works differently because, at least in many places, or some places, mariculture is habitat disturbing or destroying, particularly some of the shrimp mariculture in areas of mangrove forests. And in that case, tearing up those habitats releases CO2 and causes acidification or contributes to acidification and warming. So that's a problem. And then mariculture can also harm the habitats themselves, and biodiversity can, through release of invasives and genetic releases. Sense of place can, by overspreading beaches or places where people wanted to go, and tourism and recreation. So we can't pull all of those second order effects apart yet. We know they're there. We've got some of them, but we can't do them all. So the question is, where's this thing going? And I'm going to show you a couple of slides that tell you that. First of all, it's pretty clear that the global study is good for planetary guidance. I mean, you want to know how your whole planet's doing, and this kind of study is good. It also offers comparability between countries, but it's not a really good tool for a country managing itself because the data are too coarse. The country may have better data on fisheries or some other thing than are globally available. So trying to develop regional applications that use the general method but allow countries to substitute their own data, their own reference points, and weight some of their own values. So we've just completed this one. This was published yesterday. This is a regional ocean health index for Brazil, in which all 17 of the coastal states were evaluated, and that's online at +1. This one, the U.S. West Coast, is in, we hope, final review and will be published. And this time we broke the West Coast into 5 subregions and could see differences between Southern, Central, Northern California, Oregon, and Washington in different goals and also in their scores. So we're going that way. We've got quite a number of countries involved, you'll see. In international applications, several of the UN projects, and including the World Ocean Assessment and the Conservation of Biological Diversity are using or considering the index for one of their indicators. So that's nice. The high seas in Antarctica are being evaluated as we speak, and in a couple of months you'll have those values available so that the whole ocean will have a score. Finding benefits, by the way, from the high seas is not so easy because there's no tourism and so forth. Is there sense of place? There might be. Sense of place is funny. As I mentioned, there are places that are uninhabited, they're way out in the Pacific Ocean or somewhere, that have high sense of place scores because they are historical memorials for World War II actions or things like that, and they have great meaning for people, even though they'll never go there. So we'll see about that. So we have regional applications in place in these locations: Ecuador, Peru, Brazil, in the Mozambique Channel, and it's really in the Baltic countries for the Baltic Sea, China, and Fiji, and this is for the oceanscape out there. And we'd like to do further studies, have countries do them in Mexico, Europe, and there. So we hope that that'll happen. There is a little problem, which is that all those databases, normalizing all the data, gap filling everything, it's really complicated business. And if you read the supplementary online information, you'll see that. So to try and make it easier, the team at University of California, Santa Barbara has developed a toolbox which will be alpha ready sometime in the next month or two, which has all of this, all of the guts of this thing automated so that you'll be able to see how a particular component affects a score or how a change in a component. You'll be able to do scenarios, how this would change your goal, and so forth. It'll make it a lot easier for people in these different places to do their studies. And I'll just show you quickly a couple of things that you learned from a regional study. I showed you this already. You can't compare that and that. This is the global U.S. score directly, but nonetheless, it's interesting to see no natural products in California. They just don't extract any of those things that we are measuring for, those things for which we had global data. They did do some kelp harvesting, but they don't anymore. So there's big discussion about whether that's going to be zeroed or grayed out. We grade it. And also, you'll notice that this is mariculture is pretty low, but fisheries is much higher in California than in the U.S. because we had better data and better reference points. So the habitat goals scored lower than done on the global basis, probably because we had better data. So just because you have better data doesn't mean you're going to get a better score. It could mean you get a worse score because you're looking more closely. And the other thing that was interesting was an expert group that was set to the task of weighting, giving regionally appropriate weights. So normally these would all be 0.100 if you want 3 decimals. So 10% to each goal. And they said, oh no, well, we'll talk about that for a couple of days. And here's what they did. They gave 20% of the value to clean waters and 18% almost to sense of place. Whether any other group places would do that, I don't know. They didn't lose any of the goals. They just took a point here, a point there. Actually, they took off more out of livelihoods and economies than I would have guessed. But the upshot was it didn't change their overall score, but a couple of points. They developed a much better fisheries reference point using maximum sustainable yield and the relationship between biomass in the ocean and biomass at MSY, and also fishing mortality and the relationship to fishing mortality at MSY. So that's, you can't do better than that. So that was great. Mariculture had a different goal in this case. Remember I said for the global, we were doing mariculture based on coastal population distribution. Well, there was an established reference point. NOAA said that the mariculture production in the United States should increase 350% over its value in 2005 by 2020. So we worked with that and figured out a way to use that as a reference point. Artisinal opportunity in the global study had been based on need estimated as the per capita purchasing ability relative to the per cap GDP. And so it was basically countries that were poor had high need for artisanal fishing. Here, we did it differently, and in this case, it was, okay, people who need to fish artisanally, they need 2 things. A, access to the coast, and B, there ought to be something to catch. And we were able to, because of the nice studies there, say how much there was to catch, and then we did and accessibility should be, well, you should be able to get to the ocean within a mile of wherever you are. That was interesting. And then, but what if it's by boat? This one is a little controversial. Boat launches aren't 1 mile apart. But if you have gas and you can afford it, then you can get there, or you can trailer your boat. So we used fuel price as a proxy. Anyway, tourism and recreation. This is interesting. The first global analysis in 2012, we used international arrivals at airports. And then we distributed them on the basis of a population model. That was the best we could do because there's no data on domestic tourism. So all the domestics were gone. In the California one, there were data on 19 different kinds of coastal recreation. They had data for kayaking and bird watching and every other thing that Californians love to do. And so we were able to do a temporal analysis from comparing 2000 to 2010. It wasn't so easy as it sounds. But anyway, it changed the tourism result for California, extrapolated from the U.S. result, which was like a 1 to nearly 100. So that's the value of, or the importance of reference points. And also for sense of place, we had much better data for pollution. We didn't have to use a dispersion model. We could actually use muscle watch data for all of those nasties that we heard about yesterday. And for pathogens, we didn't have to use the proxy of percentage of population served by sanitary facilities. We could use real data on the percentage of days in which beaches were closed by the EPA because of high pathogen counts. So it was a much more direct kind of a thing. Anyway, we're coming to the end. Don't despair. For California, because it's a data-rich place, we were originally calling it California Current. It's U.S. West Coast now. We were able to get data on status, not on pressures. So we could do the status score for a 10, hindcast it for 10-year periods for 8 of the goals. And in all of those cases, interestingly enough, there's a slight decline in the status scores, almost all of them. So it looked like things were, in the past 10 years getting sort of worse. But when you look at the likely future scores, they're actually getting somewhat better. So this thing looks kind of complicated. Each one of these boxes is a subregion. Each one of the dots is one of the goals or other, it doesn't matter. This is the status score on the x-axis, and on the y-axis is the likely future status score. So anything above these lines, the likely future status is higher than the status, and it looks like that goal will improve. So we've got a sort of a conflict which says that in the past, the status was going down slightly for the past 10 years, but if you consider trends, pressures, and resilience to get likely future status, those seem to be going up for most, not all, in all areas. So that was good. And the last thing we were able to do is some scenarios asking these questions, what if land-based runoff of nutrients and pollutants had been reduced by 25% 5 years ago? And, what if we had extended the area of coastal wetlands by 10% over current levels? Or, this was an interesting one, what if the Marine Life Protection Act had not been passed and the current system of marine protected areas hadn't been established? What would the goals scores look like? And that's what they look like. If you decreased nutrient input and chemicals, lots of the goal scores would go up. If you did habitat restoration, let's see how we frame that. Yeah, if we had extended coastal wetlands by 10%, you get a couple of goals going up pretty strongly, those being coastal protection, tourism, recreation, and also, of course, habitats and biodiversity. What if you did the hadn't had any marine protected areas? Well, you get decreases in species, lasting special places, of course, and a couple of other things, biodiversity and species. But if you kept at it and made a couple of other things, you'd get probably increase in fisheries, decrease in species, decrease in lasting special places, and so forth. But you see these things begin to spin out into stuff that managers would like to pay attention to, just as a guide, not as a numerical predictor. So we think it's useful. We hope so. These guys think so. These guys think so. We hope you think so. And if you do, then you can tell us at the website or in any other way you can. I haven't gone on too long, and I hope it's raised some good questions on all aspects of this, because it's pretty interesting stuff. And the good thing is that almost all of you are experts in one or another part of it. And so we're eager to hear what you say. Thanks. Thanks. Okay.
Regarding the marine protected areas,
Yeah.
how does that calculate if you remove it? How do they know the changes in species and diversity and so forth? What are they using?
Oh, you don't know that. The only thing you know is how marine protected areas figure into the calculation of the scores. And that's done, the reference points are, it's in several goals, and it's also in resilience. So for instance, in resilience, the presence of marine protected areas acts as a plus for biodiversity and for a number of things that's factored in there. But not what's in that area is not counted. We don't necessarily know that. And similarly for that sense of place goal, the lasting special places sub-goal has a reference point of 30% of the coastal waters out to 3 nautical miles and 1 mile inland being in protected status. And then 10% of the area more than 3 miles out. So it's that kind of a thing. All those details and benefits are implicit. I wish we knew, but thanks. Yeah.
I know this is a really complicated model, but one question that occurred to me was hinted at in the very beginning: where will be underwater in the future? Is there any thought of incorporating the rising sea level and things like that?
It's in there.
It is.
Yeah, it's one of the pressures under the climate change quartet, I think, has sea surface temperature. It is sea level rise, acidifications there, and also ultraviolet is there, ultraviolet irradiation. So sea level rise is, for the most part, it's a people problem. There are, if it occurred gradually, and if we hadn't hardscaped all of the areas inland, a salt marsh would simply migrate back, and mangroves would do the same, and so forth. Over time, it would bounce out.
Also, like the stronger storms, like
Yeah.
flooding, wastewater treatment.
Oh, yeah. Yeah, and all that stuff is, in a way. I mean, as I say, there are some animals and plants that are going to be directly affected by sea level rise. Turtle beaches, for instance, some of the seabird breeding areas are a mess. If they can't find other places, they're cooked. Others, given time, can grow or migrate backwards. So it's the people that are the immediate problem, and I think you're absolutely right. If infrastructure fails, then you get a sudden and big dose of contaminants, certainly coastally. So I don't know what else to say about that. That part's a mess. And that's why this index is about benefits to people. If people don't thrive, the ocean is certainly not going to thrive. Yes.
So you mentioned people problems and also complicated models and health index.
Yeah.
And I was just curious, because it sounds to me like the core of the problem is human behavior, with people acting out in the natural world whose detriment. Is the ultimate goal the index to keep assessing it, to get on the other side of how complicated it is? So I thought it was interesting how the model was had a lot of aspects to it, but I was wondering if you're trying to get to the other side of the complexity to have something simple and actionable for human populations to follow. So for the problem, how can we fix it?
Yeah.
And it's so complex. Is that something you're addressing with human behavior and putting into action, besides just measuring a certain?
Yeah, well, we're trying to do a few things. First of all, it is complicated, but so's this. That doesn't seem to bother you, does it? You know how to use this, and you trust it, or a watch,
Well, it's great. That's actually an example, just because they're just doing some that's complicated, some that's complex. Right?
Yeah.
That's very simple to use.
Yeah.
To make it. And that's
Yeah, so the goal is, first of all, to change the perspective so that people will, agree that ocean health is a reasonable concept. There was big academic fights about this for a dozen or more years. Interesting to read about, hopefully gone. So first, the idea of ocean health, then the idea of how this perspective of a coupled human ocean system and evaluating its health in terms of the flow of benefits sustainably gained to people, so that